Hello everyone, let's study about rainbow in this discussion. A rainbow is a phenomenon due to combined effect of dispersion, refraction and reflection of sunlight by spherical water droplets caused by rain. To understand this, we have seen that rainbow contains 7 colors in a circular arc. The colors are in the order of Vibgyor. It has these 7 colors, but these 7 colors are basically split from a white light. So we need a source of white light naturally, and the source which we know is a sun. So a primary condition for rainbow should be a source of white light, which is the sun. And also we need some kind of a medium which would disperse this white color. Naturally, the medium which is present is water droplets that occurs during rain. So the two conditions which are required so that we get a rainbow would be the presence of sun in one part of the sky, which would act as a source of white light. Suppose somebody standing here and facing this side, then we also need a material which would disperse this white light, and that would be the water droplets. Now here, observe that the water droplets and sun should be on the two sides of the observer, so that the light from here, light from this falls on the water droplets, and then under some conditions, keep in mind that not every white light would be dispersed, only at some conditions some part of it would be reflected and it would be reflected back to the observer, which has been split. So we need sun in one part of the sky, and also we need water droplets in the other end of the sky. So these are the conditions which are necessary to observe a rainbow. Now this rainbow can be categorized into two categories called as primary rainbow and then secondary rainbow. Let's look at them one by one. In a primary rainbow, it is formed due to 2 refractions and 1 reflection. You will see this with help of a diagram. It also has violet at the inner edge and red at the outer edge. And also, primary rainbow is brighter than secondary rainbow. To understand this in a better way, let's draw with the help of a diagram. As given here, we'll consider a source of white light. I'm using another color here because white light wouldn't be visible in the white background. Now, this white light is coming from a rarer to denser medium. Now, somewhere here is center of curvature of this droplet. Draw normal at this point. The light ray would bend towards the normal, because of which the light would refract, and since it is white light, it would disperse also. We have seen that the violet color will have the highest deviation compared with red color. So violet splits like this and red would split. I'll draw red later. Let's first draw the violet color alone for now. Now here, the angle made by this light, if this angle here is more than critical angle for the water air interface, this light will undergo TIR. It comes out like this. And finally here, draw normal. This light ray is moving away from rarer to denser medium, so light ray would bend away from normal like this. So this is how light ray would be seen. If you draw one more end of this spectrum, which is red color, you can draw it as given earlier. So it falls like this, it's like this, it comes out like this. So this is for the red color. If we have an observer somewhere here, and suppose imagine this is the line of sight of the observer as given here, then this angle would be more than this angle. Now generally most books it's given as around 41 degrees or 40 degrees, and this will be around 42 degrees. This is what would a primary rainbow look like. As seen here, it will have violet at the inner edge and red at the outer edge. To understand this, keep in mind that not every drop would disperse at the same way. That is, if we look at one water drop here, what is seen is, in this case, all the colors are dispersed as seen here, but not every color from this would fall on observer. So in this case, as seen here, from this water drop only red color is falling into the observer's eye, not every other color. If you look at few water drops, then what is seen here is, it is seen that red color from this is falling and from here violet color is falling. So if we look at a rainbow, then what we get is something of this kind as seen here. The violet is inside and red is outside. Every water drop from here, every drop from here would refract and disperse and reflect such a way that from all the drops violet would fall in the person's eye. So if you observe somewhere here, so violet from here falls. Similarly from here, from water drop, from this water drop, red color for the person's eye. So keep in mind that from a given band, only that color will fall in the person's eye. It's not that even this will disperse also, it will have red also, but the red from here doesn't fall in the person's eye, it goes away. So you have violet from here, this violet will go away also. So for a given band, only the colors from that band would fall in the person's eye. As told earlier, here light is refracting, that is dispersing, and reflecting, and again refracting. So in case of primary rainbow, we will have two refractions and one reflection. This is called as primary rainbow. The next is secondary rainbow. Now this rainbow is formed due to two refractions and two reflections. Now here it has red at the inner edge and then violet at the outer edge, which is opposite to the previous case, which was a primary rainbow. And since it undergoes more number of reflections and refractions, it will be less brighter. As seen in theory part, if a light ray undergoes more number of reflections or refractions in each phenomenon, in each case the intensity would be decreased. The more and more light refracts or reflects, it loses intensity in each case. Hence, the secondary rainbow is less brighter than primary rainbow. Again here, we'll draw a diagram to understand how it would work. Let's take again a source of white light. I'm using yellow here to differentiate from the white background. So this would be the white light. Again, we'll draw the extreme colors. We'll just draw violet for now. Violet falls like this. So here it would disperse. Again falls like this, because here it undergoes TIR. Here it undergoes TIR. The angle, instead of refracting here, the angle of incidence at this point is more than critical angle, then light would undergo TIR. Again here also, the angle of incidence is more than critical angle, light undergoes TIR and light finally comes out like this. Similarly, if we look at the other extreme color, which is red, so light would fall like this and like this, like this, and comes out like this. So if you have observer whose line of sight is made here, then we get angles made here also. I get an angle made here as well as angle made here also. This would be 51 degrees and this is 54 degrees. As seen here, second rainbow would have red inside and violet outside, and this is primary where violet is the inner edge and red is outer edge. As seen from here, it's very obvious that the primary rainbow would have more brightness than secondary rainbow.